So, you're going to go at lightning speed through this. So heads up. Transformations. Transformation is an operation that maps the original figure onto a new figure. Okay? Just takes an old guy and transforms it into a new guy. Okay? The new guy, well, if you take a picture of yourself on your phone, that's your image, right? It's an image of you. Well, then what are you? What are you, the original, going to be called? You're called the pre-image. So if you've ever taken a selfie of yourself, you are a pre-image. And the picture you took is your image. Okay? Now, in this graph over here, I have an original pre-image and then the transformed image. Okay? Guess which one is the pre-image? The original boring triangle ABC. Okay? What about the new guy? Do I have a guess for Candy? How do you name this guy? Yes, ma'am.
With a little quotation.
Okay, so how would you say that out loud?
Triangle ABC quotation.
No, but good try. Somebody else want to try it? Yeah? I can't hear you.
Is it like A prime, B prime?
Exactly, A prime, B prime, C prime. And so I wonder what the original picture for Optimus was so that we end up with Optimus Prime. Who knows? Okay? And so you can always tell which one the original is because it's just the plain letters. And then the image is always going to have the primes on it. What if I moved the image to another guy? So this is A prime, B prime, C prime. What if I moved him? Then you'd have a double prime, B double prime, C double prime. And that's a mouthful. But yeah, you can keep on going. You can have triple prime or quadruple prime, and then we start doing other stuff. Okay, but for us, we're not going to ever go that far. Okay? Now, transformations can change everything about a shape. So what are things you can change about a shape?
Size.
You can change its size. What's something else you can change?
Orientation.
Hello?
What does orientation mean in terms of this?
Location.
No, it's about which way it's turned or which way it's pointed. So right now, B is on top. If I turned it and B was off pointing to the right, that's changing its orientation. So where it's rotated. Okay? That's what orientation is talking about. What else can you transform?
Location.
Its location. Okay? Those are all the different things you can change. A rigid motion is where when you change it, nothing about the shape changes, just its location or orientation. So a rigid motion is a transformation. There's supposed to be an S in there, transformation, that preserves or keeps the size and shape of a figure. Okay? So it keeps those two things the same. Okay? But it might be moved to a new location. Or it might be turned sideways. But it's going to be the same size and the same shape. So if it's a 30, 60, 90 right triangle, then by golly, a rigid motion is going to keep it a 30, 60, 90 right triangle. It might be somewhere else on the graph, it might be turned, but it's still going to have the same size and shape. Okay? And so all the corresponding sides and angles, so corresponding sides and angles of the pre-image and image are going to be the same. Okay? So your sides will be congruent and your angles will still be congruent. So remember how we just finished doing congruent triangles? any rigid motion will keep your shapes congruent. Every angle, every side that corresponds should be the same. So which of these guys, okay, are going to, which kind of motions are going to be rigid motions? They start with T's or R's or stuff. A translation, which is just a slide. Okay. What's another one that will preserve size and shape? A reflection, where you just flip it over. That's going to do it. What's another one that will preserve size and shape? Rotation. See, y'all have done most of these already, so we're going to fly through this really fast because you've seen this like in 7th grade. Okay? And so people aren't getting their candy when they answer stuff right. That's unfortunate. So someone describe what a translation does. What does a translation do to a figure? How would you describe it to like a 5-year-old? It's a slide. Which way? Well, which ways could those be? So vertical, or what's the other way it could go? Horizontally. Ah, this guy's dying. Horizontally, or both. If you do both vertical and horizontal at the same time, what do you end up kind of doing? A diagonal. Okay. And the way you show someone how you want to move it is you say, okay, if I had an original point, let's call it X, Y. Okay? And I want to move it, I'm going to show XY needs to be moved to X plus H and Y plus K. How did that tell me how to move? What does the H represent, do you think? Well, I'm moving the X. If I'm moving the X, which way does X go? Horizontal. So this H number is the horizontal shift. Okay? And so guess what K represents? The vertical shift. Now why wasn't it V? Why isn't H and V? I don't know. It would make more sense if it was H for horizontal and V for vertical. But they didn't do that because reasons. So K is your vertical shift. Okay? And so in this one, my original is triangle ABC, A prime, B prime, C prime. How much is the horizontal shift to get from B to B prime? And you can count. 1, 2, 3, 4, 5, 6. So my horizontal shift was 6 here. To go down to B, how much was the vertical shift, which is K? How far did B go? 1, 2, 3. So we down 3, so your K is a minus 3. That's all it is. That's how you read it. Now, out of the kindness, goodness, and generosity of our kind, good, and very generous hearts, we're not going to make you graph things. You're allowed to do all the work without graphing. Now, if you want to graph, can you graph to make sure you've done everything right? Yes, but the nice thing is you don't need to. Here is my coordinate notation for the translation. It tells me how the coordinate changes. Okay? Do you need to know coordinate notation, what I'm asking for when I say that? Yes. You should know that it looks like this. This is how you write the coordinate notation of a translation. Okay? And so when you see this, it says to take whatever x you had and do what to it? Add 5. And what are you supposed to do to your y's? Okay, so I need a victim who wants candy to tell me where Q ends up at Q prime. Where should Q prime end up at? Yes, ma'am.
Negative 1, 6.
So negative 6 plus 5 is negative 1. Yep, I agree with you. And what was the y value again? 6. There it is. Get your candy. She took the x, negative 6, and added 5 and got negative 1. Took the y was negative 1 and added 7 and got 6. Do you want to graph it to make sure it's right, or are you going to trust her? It's up to you. I don't care. If you want to check her, check her. Okay, I need someone else who wants to do r prime. I need r prime, s prime, and t prime. What do you got for r prime?
I got 2 for x,
Uh-huh.
8 for y.
And 8 for y. I agree with you. S prime. Next victim. Yes, ma'am.
Me?
Yes.
X is 6, and then Y is 2.
Is how much?
2.
2. Thank you. And t prime. Okay, I get to call on people. Yes, Maria.
Oh, x equals 0, y equals... No, x equals 3 and y equals 0.
Let's see. For t, x equals 3 and y is 0. There you go. If you draw these, it should look exactly the same, just slid. It should have slid sideways, 5 to the right, and then 7 up. And you could graph it if you wanted, but if you trust that you know how to add, you don't need to. Questions about how to graph a translation using coordinate notation? Cool, turn the page. We're not going to do another one. Y'all know how to add. Without graphing this one, someone tell me which directions this translation is going. Raise your hand so I know who you are. This whole table's already done it. I need to, it's somebody from this table. Hannah, which directions is this one going? What's x plus 2 tell me?
That it's going to like increase.
Which way, right or left?
Right.
So this is going to go right 2, and then the y minus 2 tells you
That it goes left or it goes down.
it goes down 2 because y is a vertical component. Okay? So you've got your horizontal component and your vertical component. Yay! All right. Moving on. Vector. What's a vector? If you guys don't know this, you have missed out on a critical element of your childhood.
Factors from the...
Yes, I know. We watched the very educational movie. So what's a vector?
A bad guy.
No. It's a quantity or motion. Okay, it's a quantity or motion with what? Somebody's going to get it right when they're brave enough to say it out loud.
Direction and factor.
Direction and magnitude. They were not lying. And so, yes, we have watched this very educational movie about vectors in this class. Okay? Because it's actually correct. A vector is a quantity or a motion with a direction and what's magnitude? I know what direction is. What's magnitude? Like how big something is. It's its size. Okay? And so a vector is going to be represented by an arrow because it's a motion. I'm going from here to there. So it's represented by an arrow from an initial point to a terminal point. Guess what terminal means? Guess what terminal is? End. So like when you go to the airport and you're in the terminal waiting for your plane, or you get off the plane, it's literally the end point of your flight. Even when it's the beginning point of your flight, it's the end point. Okay? So you've got a beginning and an end, an initial and a terminal. In this picture right here, which one is the initial point, P or Q? How do you know it's P?
The arrows going in the direction.
The arrow's at the other end. So this one starts at P and goes to Q. Okay? Now, to denote the vector, you say the initial point first, so P. You end it at Q because that's where the arrow's going to. And then to show that you're talking about this motion, you put an arrow over it, which is kind of like how we did rays, isn't it? And rays started at the point and ended at the arrow, so it works just like rays do. Okay, so this is vector PQ. And you say it that way, vector PQ. How do you know if I'm talking about a ray or if I'm talking about a vector? Context. If we're talking about transformations and I say vector, you're probably, and you see an arrow, we're probably talking about vectors. If we're drawing a picture of a triangle and we're not on a coordinate grid, chances are good it's just a ray. Okay? Okay? So the component form of a vector, if I wanted to say, hey, how far is this vector moving? Okay? How far is this vector moving? Well, what directions did it go?
Right.
It went right. How far to the right did it go? 4. And it went
Up.
up how far? 7. There you go. So the component form is written to say which directions it goes. And so you say, I want to go to the right 4, I want to go up 7. And so you put them as if they were coordinates. But instead of coordinates, they are components of the vector. And so instead of parentheses, we don't want to mix this up with a point. So instead of parentheses, we're going to use these little arrow brackets. So these little arrow brackets, instead of telling you the 0.47, they don't tell you the 0.47. They tell you your vector is moving right 4 and up 7. And see how they almost look like sideways V's? So vectors get the sideways V's. These are technically called angle brackets. So if you need to find them on your computer keyboard, they're angle brackets. They look like greater than or less than signs, but we're using them as angle brackets, okay? And this is your horizontal component. And so you go A, B. A is always your horizontal component, B is always your vertical component. And so I should have put that 4-7 here. Okay? Y'all, we're not supposed to be having fun, you're supposed to be suffering. Okay? So here. Okay, I need people who have not yet answered, but who do candy. I need the name of this vector and then its component form. Okay, so let's see who I can pick on that hasn't talked much. Katie, what is the name of this vector?
WV.
And so you'd say vector, WV, and then its component form, remember, you put in the angle brackets. Which way is this vector going?
To the right.
And how far to the right?
A distance.
How far?
9.
Is it 9? Thank you for helping out. And then how far up?
3.
Okay, so this is the name of the vector. This is the component form of the vector. It tells you how far the vector goes. It says this arrow goes right 9 and up 3. Okay? What about number 8? Someone tell me the name of, oh, no. We definitely need to do number 7. So I need a victim for number 7. Let's see, Cruz.
The vector is SR.
Oh, you forgot to say vector, SR.
Yeah, vector SR.
And what is the component form of that vector? Is it RS or SR? I heard someone arguing. Excellent.
SR.
How do you know it's S first?
Because the arrow's pointing towards the R.
Because the arrow's pointing to it. So are you guys going to want to make sure you're careful so you don't get bamboozled on a quiz or a test? Because alphabetical is not always the way it's going to go. Okay, and so you're going to have to watch out for that. Okay, and then go ahead, continue, Cruz.
It goes to the left.
How far to the left?
Twice.
So how would I write that as a component here?
-2.
Perfect. And then my vertical component?
It goes down 11, so you write -11.
Perfect. So this vector goes left 2, down 11. Another vector, number 9.
Wait, no, I counted 10. Yeah.
Oh, you counted 10?
11.
Is it 10 or 11? 1, 2, 3, 4, 5, 6 and 5 is 11. I see 6 and 5.
Right.
Okay? Okay, number 9. Let's see, Eladio.
Vector MR, MN,
Which is it?
MN,
MN. And then, what am I going to put for the vector?
0 and then 6.
0, 6. I'll buy it. And so yes, you can say don't go sideways at all, just go straight up or down. And that's fine. Okay? All right. How are we going to use these vectors? Well, the vectors can tell us how to translate. So, okay, shh. So, here we've got, this one I want you to graph it. So go ahead and graph my pre-image triangle STU. So S is at -4, 2. T is at 5, 1, -1, sorry. And U is at -2, -2. So I've got this triangle. That's my pre-image. Instead of using a coordinate translation, I'm going to translate this guy using a vector. The vector is telling me how far to go. Which way is it going to go each time? Well, the -1 tells you which direction. Left 1, and then down 5. Okay, so S is going to go left 1 and down 1, 2, 3, 4, 5. And it's going to end up at S prime. Where is, yes?
Oh, I thought the T was -1. Oh, never mind.
Okay. And so S prime, where is S prime? Where is this? Well, could I count it on the graph? Could I count it on the graph? Is there a way to do it without looking at the graph?
Yes.
Yes. You can say, oh, the S started at -4. It goes left 1, which ends at -5. If my Y was at 2, and I'm supposed to go down 5, where does it end up at? This is not rocket science, people. -3. And that is where this point is, and this is where the vector went. Yes?
Is the T graph wrong?
I don't know. Oh, I should have connected it over here, you're right. I connected it to the bad point instead of the good point. You're right. See, this is what I need you guys for. There. All better. See, I fixed it. Okay, so where is T prime going to end up then? Now that I have fixed where T is, where should T prime end up? Positive 4 and? -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That should be T prime. And then there's that vector. Okay. And then U prime? I can't hear be a little louder?
Positive 3, negative 7.
Positive 3, negative 7. So 1, 2, 3, I don't think so. It should be negative 3, negative 7? Because negative 2 minus 1 is negative 3. Sorry, I must not have heard you right. So negative 3, negative 1, 2, 3, 4, 5, 6, 7. Okay, so that's my u prime. Now, I graphed this one for a reason. Okay? I'm drawing all the vectors and then connecting all the dots. Does my image look the same as my pre-image? It should look the same because it's a rigid motion. What do you notice about all the vectors? Say again? They make it look 3D. Why? What are you noticing about all those vectors? They're all going in the same direction, so they have the same direction. And are they all the same length?
Yes.
Yeah, so they all have the same magnitude. So they're the same length, they're going the same direction. They're always parallel. When you're using a vector to translate something, all the vectors for every point should end up being parallel. And yeah, it happens to make it look 3D. It makes it look like a prism. So if you ever need to draw a prism of any kind in our 3D unit, when we get to our 3D unit, just draw all the arrows parallel, and you'll have an automatic prism. Okay? So, so coming down here, let's put everything together that we just did. Okay? I have a pre-image and an image here. What is my pre-image? This is all for candy, so I need people who haven't gotten candy, who want candy, to raise your hand. Yes, ma'am. What is the pre-image? Triangle DEF. Okay. What is its image? Let's see, Matthias. Okay. And then what is my translation in coordinate notation? Can you remember? You might have to look back. What does it look like to tell me the translation in coordinate notation? Will you start off by telling me what? Coordinates. What are your most generic coordinates in the entire universe? X and Y. And then to describe the translation, how do we put that in coordinates? For this guy, well, what did my X do to get from D to D prime?
Right.
How far to the right?
7.
So I would, is it 7 or 8? Ooh, fight. 1, 2, 3, 4, 5, 6, 7. I think it's 7. So what would I write here?
X plus 7.
X plus 7. And then what's my vertical coordinate translation?
Y plus 4.
Y plus how far? 4? Okay, so that's your coordinate notation for the translation. Now I want the vector in component form. So what is the vector? So that's this arrow that got me there. What will my vector look like? How do we write vectors? So it's vector D to D prime. But you don't even need that because the vector's going to be the same for each one of these, isn't it? So we don't name the vector, we're just going to tell its components. So what are the components of my vector? And look, you can see it here in your coordinate notation. I should have a 7 for my horizontal component. And what's my vertical component? Should be 4. Okay? These both tell you to do the same thing. They're just different versions of the same thing. This one is the translation in coordinate notation. This is the vector in component form. They both tell you to slide the image to the right 7 and up 4. Okay? Questions about translations and vectors? Yes?
You gotta add time on the F.
Oh, on the F, you're right. You caught it. Good job. Get the candy if you want it. Okay, turn the page. Okay, what's a reflection? How would you describe a reflection to a 5-year-old?
Mirror.
Over a line.
Flip over an eye.
It's a flip.
I literally.
Flip and flip. Yeah, but you gotta say it loud enough for me to hear it if you want the credit. Okay? And we flip it over a line. So everything gets flipped across the line. Can I have a victim who wants to tell me what you think the name of the line is that we flip it over? Yeah, Albert? It is not an axis. Because you don't, could you flip it over an axis?
Yeah.
Yes, but you could just flip it over another random line. So we don't call them axes. The line we flip it over is called something else. Don't make it harder than it is. Yes. It's just the line of reflection. That line could be an axis. It could be just any old horizontal line. It could just be any old vertical line. It could be a diagonal line. You can place your mirrors anywhere in the picture you want, your line of reflection, okay? Each point and its image, so each pre-image point and the image, are the same distance from that line of reflection. And you'll find this is also true in physics. So what year do y'all take physics? Is it junior year? You're going to learn about actual literal reflecting off a mirror, and the image in the mirror is always the same distance from the mirror as the original. It always appears to be the same distance across. Okay? A reflection is also a kind of rigid motion. So is a reflection supposed to change the size? Nope. Should it change the shape? Nope. What does it change? Location and orientation. Okay? So it could change both. Some common lines of reflection are the x-axis. That's a popular one. The y-axis is another really popular. We could use vertical or horizontal lines. Ooh, how do you show a vertical line? What's the equation for a vertical line? Vertical line. If it's vertical, what always stays the same? The x thing, the sideways thing. So it's always x equals a number. Remember hoi and vux? Horizontal is always a y equals, vertical is always an x equals. So this is vertical, is always x equals. What about horizontal? It's going to always be y equals some number. Could I reflect across a diagonal line? How many different diagonal lines can you draw on a graph? Could I draw a diagonal line here? Could I draw a diagonal line here?
Yeah.
Could I draw it way over here? Yeah, so there's infinitely many. We're not going to use that many. We're going to stick to the basics. We're going to stick to the basic y equals x. Do you know what that diagonal line looks like? It goes through the origin and just goes up one over one, or down one, left one. Or y equals negative x, which also goes through the origin. We're going to only use those two to keep it simple. Okay? And we'll talk more about those in a minute. If I reflect over the x-axis, okay? So if I take this point and reflect it across the x-axis, I'm at -4, 2. I'm at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and 5, 1. 1, 2, 3, 4, 5, 1. So A, B, C. There it is. If I reflect this across the x-axis, here is my x-axis. That's what I'm reflecting across. Everything has to be the same distance from this line. So if I take C, it's 1 above my axis. So where's it going to end up when I reflect it? It's going to end up 1 below it. Well, what point is that at C prime? It's 5, negative 1. What do you notice about the two sets of points? The y is the only one that changed. When I flip across the x-axis, x stays the same. Okay? And so here is the rule for a reflection across the x-axis. If I take the point xy, my x is going to go to, it's going to stay the same. But what happens to the y? What happened to the y here? The sign changed, and so the sign flips. This is your rule for flipping across the x-axis. Okay? So where do you think B prime is going to be using this rule?
4, negative 7.
It's going to be 4, negative 7. And where is A prime going to be? Negative 4, negative 2. Does it look reflected to you? If I drew better? Yeah, that looks better. Do you have to draw them? No. Could it be helpful to make sure you've done it right? I hope so. All right. What if I reflect across the y-axis? What do you think is going to happen when I reflect across the y-axis? The y stays the same. So my rule for reflecting across the y-axis, I need someone who wants candy to guess what you think the rule is going to say for this. Ooh, I've got a couple people. I'll pick Katie. Yeah, flip the sign on the x, so negative x, and then y stays the same. Okay, so Maria, since you had your hand up, I'll let you get candy for giving me P prime.
Negative 1, 2.
Negative 1, 2. Okay. What about S prime? Amy, give me S prime.
S prime is
Negative 7, 0. What if I had a point, K, that was at negative 3, negative 4? Where would K prime be? Yes?
It was negative 3.
It was originally negative 3, negative 4. Where would that go to if I flipped it across the y-axis? It'd be a positive 3. Because if I negative something that's already negative, it goes back to being positive. Okay. Yay! Questions about doing these? Do you have to memorize this? Smile and nod. Yes, you do. But all you have to do is remember the rule. For the x-axis, the x stays the same. For the y-axis, the y stays the same. And then you can use that to help yourself write down the rules if you need to. Okay? What if I reflect across a different vertical line? This is where it gets tricky. Okay? Here it says, flip across the line x equals 4. What kind of line is this, vertical or horizontal? If x equals 4. It's going to be vertical because you're supposed to be able to come across and go 1, 2, 3, 4 on the x. If you can do 4 on the x-axis, then you know you've done it right. So it's going to be a vertical line right here. Okay? Now if I want to reflect across that vertical line, Can I just opposite my numbers? No, but what will stay the same if I reflect across a vertical line x equals 4? Well, if I reflect across a vertical line, what's going to happen? The y will stay the same. So this one looks backwards because it says x equals 4, but since it's a vertical line, the y stays the same. Okay? And then for these ones, you're just gonna have to graph it. This is the one time where I'm gonna say graph it, and then what you're going to do is count your distance from the line. Okay? So if my original pre-image is at 1, -1, there's J. What did I tell you was always going to be true about the point in the image? They should be the same distance from that line. How far is J from that line? 3. So its image should be 3 more past it. Well, what's 3 more past 4? It's going to be at 7. But then my y is going to stay the same. Okay? So I reflected it over here. Let's try another one. It's kind of weird at first. Okay? So for point K, it's at 2, 1, 2, 3. Here's point K. Graph it. If I reflect it across this line, is it going to stay the same height up and down? Mm-hmm. Yeah, so my y should still be at 3. How do I figure out where the x is? I count over. How far did I have to go to get to my line of reflection? I had to go over 2. So to get to the image, I'm going to have to go 2 more. Has to be the same distance. And then all you have to do is figure out where that is. What's 2 more than 4? And you say it's over at 6. And that's your K prime. L is at 3, -2. So where is L prime going to be up and down? Where do you think L prime's going to be? It's still going to be down at -2. I just need to figure out how far sideways it is. Well, it's 1 below 4, so its image should be 1 above the 4, which is where? L is at 3, right? L is at 3. I have to go up 1 to get to my mirror. So to get to my reflection, I have to go 1 to the right. Well, what's 1 to the right of 4? 5. Okay? So all these distances should match left and right. And these can be difficult to do in your head, and you get confused. So I very, very, very highly, way up here, guys, very highly recommend draw these ones. Okay? Do you want to do it with a horizontal, just for giggles? No? Okay, well, where would the line y equals 5 be, or -5 be? What kind of line? Horizontal line at -5. 1, 2, 3, 4, 5. It's crossing a vertical line, but it's being horizontal at -5. These ones confuse people. That's why I recommend you graph them. If it says y equals -5, go down to -5. Everywhere on that line should be down at -5. Okay? And so then if I just do one of them, m is at -6, -8. So there's m. If I reflect it across the line, is my sideways distance going to change at all? When I go up above here, is my sideways distance going to change? No. So your x is going to stay the same. And so my x is still going to be at -6. But how far is it from -8 up to that line at 5? How far was it?
3.
It went up 3. So my reflection should be 3 on the other side. Well, what's 3 above -5? And it should be at -2. And you can count that and just say, there it is, at down 2. It's at -6, -2. There it is. But these distances should be the same. Okay? You scared? Okay, let's make it worse. Remember how I told you we were going to do just a couple of the diagonals in the world? We're only going to do a couple of them. Okay? The line y equals x. Well, guys, it tells you what it looks like. If y equals x, what points will it go through? 0, 0, because 0 equals 0. What other numbers equal each other? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. This is the line y equals x. It's just a diagonal line with a slope of 1. Okay? Now, here's the fun part. There's a trick to this one that you can memorize so easy. If I want to reflect over the line y equals x, okay? I take my point xy, and the line tells you what to do. What is my x-coordinate supposed to equal? Y. So my x is going to change into what the y was. I know. And what does y supposed to equal? So what is my y going to change into? My x value. When you reflect across the line y equals x, your y thing needs to equal your x thing. And so when you reflect it, it flips. It's crazy. So if x is at -5, -2, 1, 2, 3, 4, 5, -2, here's x. Let's use that rule. Where should x prime end up using that rule? What's supposed to go in the x place? Whatever y used to be. So what was y? Y was -2. It's going to go in my x position. And your x thing should go in your y position. You have flipped their places. So that's at -2, -1, 2, 3, 4, 5. There's x prime. By the way, does this perpendicular distance look to be the same as that perpendicular distance? Remember, reflections are supposed to be the same distance from the line of reflection. So those distances should look the same when they're perpendicular. Okay? All right, let me pick on someone. Who haven't I picked on? Alexander, I haven't picked on you yet. Don't worry, and we'll get your little friend too. We'll get everybody. Where's y prime?
Y prime is -3, 4.
So y is at -3, 4. So where should y prime be?
Y prime should be at 4, -3.
4, -3. So 1, 2, 3, 4, -3, -1, 2, 3, and 1, 2, 3, 4. So there was y, here was y prime. Do those look to be about the same distance? On the left and on the right. You know you reflected it if they do. Okay, last victim at this table. We haven't picked on you yet. Who is going to be z prime?
1, -1.
Going to be at 1, -1. Because we were here, and now we're here. And they still look the same distance. Okay? Okay, this one will be worth double candy. If I want to reflect across the line y equals negative x, okay, y equals negative x is the diagonal line going the other way through the origin. So it looks like this guy. Okay? If I use this as my mirror, what do you think the rule is going to be to get xy to my new image point? This one's worth double. Yes, sir. Santi.
I think it would be like, y negative, like the y is.
Well, what do you use the equation. If you solved this for x by itself, what would x equal?
Y.
Just plain old y, huh? Sorry, incorrect. I have to pass to the next victim.
It would be negative yx.
Oh, it's not negative yx.
Negative y, negative x.
Oh, she saved it. Yeah, x will be negative y, and y becomes negative x. It's just about solving the equation. Okay? And so, let's see, Charlotte, where do you, over here at 22, G is at 2, negative 1. Using my rule to reflect across y equals negative x, what do you think G prime should be? 1, how much? Negative 2. Okay? If you do the other two, I'll let you get candy. So where's H prime going to be?
1, negative 7.
It's going to be at 1, negative 7. Okay, that's enough for you. Now we'll pass it to Nico to do the other two. I prime, Nico?
4, negative 7.
And J prime?
4, negative 2.
4, negative 2. You just flip the letters and flip both their signs. Could you then graph both sets to make sure it looks like it's reflected properly? Absolutely. Are we going to require you to graph it? No. What's the only one that you really, really need to graph? These random vertical and horizontal lines. These are the ones you really need to graph. Everything else, just use the rule. Okay? We're not done, guys. This is a heavy, heavy day. We got to keep going. Okay? So if I want to reflect a line, what if I just had a line that I wanted to reflect across y equals x? Okay? So the line 1/2 x plus 3, so it intercepts at 1, 2, 3, and it goes up 1 over 2, up 1 over 2, up 1 over 2. What if I wanted to reflect that line across y equals x? Okay? Guesses about how you do it? Okay, I'm going to tell you the rules. Step number 1, pick 2 points on the line. Okay? Pick easy points. What's an easy point? What's an easy thing to plug in for x here? Oh, if I plug in 0, what will I get? I'll get 0 times 1/2 is 0, plus 3 is 3, so the y would be 3. Should I plug in the number 1? That's going to give you a fraction. How many of you love working with fractions? Wow, so many hands. So what would be a good number to plug in here? Maybe plug in 2. If I plug in 2, what will I get for my y? What's 1/2 of 2? Plus the 3? So my y would be 4. Okay? So you take those 2 points that are on this initial purple line, and what we're going to do next is apply your rule. What is my rule for reflecting across the line y equals x? If I reflect, I'm going to switch it to yx. Okay? So where will my two new points be if I reflect them with the rule?
3, 0.
They'll be at 3, 0, and 4, 2. Okay? Once you do that, if I want to write the equation, is that enough to draw the line? Is 2 points enough to draw the line? Yeah, that's enough. Does it look reflected? Does it look pretty evenly reflected? I think it does. But I want to write the equation of the line. To write the equation of the line, I need to find its slope. So do you remember how to find slope? It's y's over run. So y's minus x's. So I'll do 2 minus 0 and 4 minus 3, which gives me a slope of 2 over 1, which is just 2. And then my last step is to plug it in to the equation. Okay? Do you remember your point slope form of an equation? Y minus y1 equals mx minus x1. Do you remember that? Let's plug in. So I'm going to do y minus, what's one of my y's? Which one do you want to use? Which point? You pick one of your points to plug it in. So do you want to use 3, 0 or 4, 2? 4, 2? Somebody picked 4, 2. So I'll do y minus 2 equals, I need an m. What's my slope of my reflection line? I have a lot of people not involved. It's going to be 2. And then x minus, what's the x? 4. Okay? Should I now put this in slope-intercept form? Yes. So y minus 2 equals 2x minus 8, and y equals 2x minus 6. And by the way, in the graph, it does look like it crosses about negative 6. Okay? So all that old algebra stuff, you had to learn how to do. Okay? So for this guy, if I want to reflect this one, what do? I'm going to pick 2 points. So what are 2 points I can use here? 0 and 1. And if I use 1 to plug in, what will I get out? 1 times 3 is 3 plus 1 is 4. Okay? If I'm reflecting across the x-axis, what's my rule? So x stays the same, what happens to y? It becomes negative. So what are my 2 new points going to be?
1, 0.
Well, the x stays the same, so the x stays 0, and the y
0, and then
negative 1. And for the other point, the x becomes the same x, and the y gets flipped to negative y. So that's your apply the rule step. Okay? What do we do next? We're going to find the slope of my new line. Okay? So for my slope, you subtract your x's and you subtract your y's. So negative 3 over 1, which is negative 3. And then your last step to your equation is plug in your slope and your point. So I'm just going to pick random person here. Zena, which of these points would you like to use? 0, negative 1, or 1, negative 4? She wants to use 1, negative 4. So I'm going to plug in to my point slope equation, y minus negative 4, plug in my slope, and then x minus the x. And then let's put it into slope-intercept form. Y plus 4 equals negative 3x plus 3. Take away the 4, y equals negative 3x minus 1. That's the reflected line equation. Could you graph your original line and your reflected line to make sure that they actually are reflected across the x-axis? Yes, you could. Do you have to? No. Turn the page. We still got 10 minutes and we're going to finish this, dang it. What's a short form letter word for a rotation? To turn or spin. I'll take either one. And it's around a fixed point called the center of rotation. Have any of you guys ever used patty paper before? Remember using that? You're allowed to use this on your homework, on your quiz, or on your test. Because when you use patty paper to do a rotation or whatever, you hold down a point and then turn it around that point. Okay? So if I hold it down, that's where it ends up. Do I have to hold down the origin? No. I could hold it somewhere else. But we're going to focus on my center of rotation being at the origin. Okay? It's going to rotate a specific angle and a direction. The angle is how far around, the angle is how far around the circle you're going to turn. Okay? And the direction is clockwise or counterclockwise. Okay? And again, the most common one we're going to stick with is the origin. Okay? So if I rotate, for some reason we like counterclockwise best. It's kind of the preferred, I know, crazy. So for a 90 degrees counterclockwise, you start here and you do a 90-degree turn to the left. So B started here, and I made a quarter turn to the left. Okay? For this, we're just going to tell you the rule. The point XY is going to have its points rearranged to be negative YX. You're going to want to have this handy with you while you work on your homework. Would you like to memorize them, or do you want us to just give you the rules? We'll consider giving you the rules for the rotations. I didn't say clockwise or counterclockwise for 180. How come? It's the same if I go this way or if I go this way. It doesn't matter. And for this one, XY is always going to just flip both of the signs. For 270 degrees counterclockwise, XY, your X becomes whatever your Y value used to be, and your Y value becomes the opposite of whatever your X used to be. By the way, what if I wanted to go the other direction? Can I do that? Absolutely. What is the equivalent of 90 degrees counterclockwise? 270 degrees clockwise. What's the same as 270 degrees counterclockwise? It's going to be 90 degrees clockwise. Do you want to do a bunch of examples together for these, or do you think you can figure out how to use these rules?
Do one example.
One example.
Never mind, no examples.
No examples? How about we just do one, just to practice using the rule? Okay, if I say 90 degrees counterclockwise, what is my rule? What's my rule for 90 degrees counterclockwise? XY becomes negative YX. Okay, so this XY for A, what's going to go in the first spot? The opposite of what Y was. So it becomes negative 7. What goes in the second slot? Whatever X used to be. So it becomes a 2. Okay? For B prime, what's going to go in my first slot? The negative of what y was, so negative 5. What's going to go in my second slot? Whatever your x was, so it's going to be 6. For C prime, what's going to go in my first slot? The opposite of y, so the opposite of 1 is negative 1. What's going to go in my second slot? Whatever x was. That's how you use the rules. Did we do it? Did we get through the whole thing? Well, if I said 90 degrees clockwise, what's 90 degrees clockwise the same as? 270 degrees counterclockwise. So that rule takes xy and goes to y negative x. And you just use that rule instead. Okay? Phew! You guys, that was an extremely dense lesson, but it meant that our unit got to be a day short by shoving all that in. So, yeah, you've got about 4 minutes until the bell, and so you can pack up if you want, or you can work a couple problems and check them, because I do have the key here. Go ahead. Hold on. Yes. Okay.